All right, let's talk about those big, beefy questions at the end of an exam. You know the ones. They can feel a bit daunting, right? But they're also where you can score a massive chunk of marks. Today, we're going to take a real 9-mark GCSE chemistry question, pull it apart piece by piece, and I'll show you exactly how to nail it using the official mark scheme as our roadmap.
So here's the game plan. First, we'll decode what the question is actually asking. Then, we'll hit all 3 parts one by one, looking at the exact answers the examiners are looking for. And finally, we'll wrap it all up into a master plan you can use on any exam. You ready? Let's get into it.
So, the question drops us right into a real-world problem. We've got these huge overhead power cables, the wiring in your house, and those tiny printed circuit boards. Our job is to figure out which metal is best for each task, and we can only use the data they've given us in this table for aluminum, copper, and silver. So we're comparing things like conductivity, density, and, of course, cost.
Right, let's tackle the first part of this question. This is all about evaluation, and that's a key word. It means you're not just listing facts, you're acting like a detective, making a smart judgment based on the evidence in front of you.
Okay, so this is the question, word for word. The 2 most important phrases here, evaluate and use Table 5. The examiner is literally telling you, don't just give me your opinion. Connect the data from this table to a logical conclusion about which metal to use and where. So, let's see how the mark scheme breaks this down.
To bag those top marks, the first thing you've got to do is lay out the evidence. These are the key facts you can pull straight out of that table or from what you already know. And look how simple these statements are. Silver is the best conductor. Aluminum is the least dense and the cheapest. These are the building blocks of your answer.
And this is the crucial part. Once you've got your evidence, you use it to make your judgments. You have to link the property to the job. So we use aluminium for overhead wires because it's lightweight. We use copper in our homes because it conducts really well, but doesn't cost a fortune like silver. Which, of course, leads to the big conclusion. Silver is just way too expensive for big jobs, making copper the perfect sweet spot, a great compromise between performance and price.
Awesome. So that's the evaluation part sorted. Now let's dig a little deeper. The next part of the question shifts gears. It moves away from the data and tests your fundamental science knowledge. Why do these metals even work like this in the first place?
It's a pretty straightforward question, right? Describe how metals conduct electricity. This is a classic test of your understanding of metallic bonding, and to get the full 3 marks, you need to be super precise with your words.
And boom, here it is, the perfect 3-mark answer, straight from the people who'll be marking your paper. Step 1, you have to mention that metals have delocalized electrons. Step 2, you need to say what their job is. They carry electrical charge. And step 3, you explain what they do. They are free to move throughout the whole structure. 1, 2, 3. That's all it takes.
Now check this out, because this is a real pro tip, straight from the mark scheme's notes. It specifically says that if you write that electrons carry current or electricity, you don't get the mark. The scientifically precise term is charge. It's that kind of attention to detail that separates a good answer from a great one. All right, on to the final piece of the puzzle. We've talked about pure metals, but what happens when you mix things up and make an alloy? The question now hones in on a really key difference in how they behave. The question asks why alloys aren't as good at conducting electricity. And look, it gives you a massive clue again. Answer in terms of structure and bonding. It's basically shouting at you to talk about atoms and electrons.
So, picture this in your head. A pure metal is like a perfectly organized parking lot, with all the cars, the atoms, being the same size, lined up in neat, orderly rows. It's easy to move through. But an alloy? That's like throwing a few massive trucks into the mix. It completely messes up the neat layers and distorts the whole structure. And that distortion, that's the key.
And that leads us straight to the perfect 2-mark answer. First, you state the problem. In an alloy, those different-sized atoms mess up the regular layers. Second, you explain the consequence. Because the structure is all jumbled, the flow of those delocalized electrons is restricted. It's just harder for them to get through, which makes the alloy a worse conductor. Simple as that.
Okay, so we've totally dismantled that 9-mark question. But what's the big takeaway here? How can we use this for any big question on your exam paper? Let's build ourselves a master plan.
Here it is, your 4-point master plan. 1. Hunt for those command words like evaluate or describe. They tell you what to do. 2. If they give you a table or a figure, you have to use it. Make explicit links. 3. Structure your answer logically. For evaluation, that means evidence first, then your judgment. And 4, use precise scientific language. It really, really matters.
And there you have it, a 9-mark question completely demystified. We've seen how the structure of a metal explains why it conducts electricity, but that same structure is also why metals are strong and why you can bend them into shape. So my final question for you is this: what other properties of metals and alloys can be traced all the way back to how their atoms are arranged? Keep thinking about that one, and I'll catch you in the next explainer.